we are going to continue where we left yesterday. We have done the covariance proof. So now we can generalize this covariance proof for derivation to some. For example, if we want to generalize it in any direction, we have used it for 3 space and time. Particle, 2 reference frames, we related them. How we can first see the covariance in general sense, and then we solve for the relativistic derivation, how the proof of that in that sense. Now, you see in that sense, in my class we had, so we had 6 parameters. Normal matrix हमारे पास होती है 16. 16 में से 4 और 0 0 इधर constant, तो हो गए 12. 12 में से 6 are antisymmetric. So it's more or less 6 parameters are covered in this sense. So the 6 matrices which are generated by this, which correspond to Lorentz rotations, and which are 4-dimensional space-time. Those dimensional generalizations of 3-dimensional space. Okay. This can be rows and columns. So yesterday we had psi of, so if it's psi of x prime, this is one coordinate system. So it's being mediated by psi of x. This is some transformation matrix S. So S can actually, S is basically what 1 minus iota by basically we have 1 minus iota by 4 sigma mu delta mu. Now this, so we have to find equivalence of this and this via this transformation. So it will be a sort of transformation for the sort of rotational transformation, infinitesimal rotational transformation. So we can, in the simplest cases, we can write it as, if you want to give higher order terms in the expansion, we can write it as so it's psi of x. So we can write this S, can be written as this S. Basically proper is T algebra. But it's infinitesimal rotational transformation that sort of operator, which will operate on side. So you have equivalence of this to this. So this to this via this transformation. So it's sort of it should be sort of in some sense.
Kind of an operator.
Infinitesimal operators operating on states in 2 coordinate systems, psi prime x to psi x. So there is a coordinate in this frame, and the coordinate in this frame. We have to show invariance in that sense, in some sense. So we specialize. Again, this transformation 19, you see, if you remember, this S, you want to write S like this. So psi prime x can be written as now, if the rotation is through rotation is through angle. Rotation is through angle. What I should say? Phi about z-axis, then so you can see I1 is minus I2, or at the end. Yesterday also we represented this I as a matrix, or like this. I represent that as a 1 0 0 0 1 0 0 0 0 0. Such that I square is going to be plus. So if you do this way, and for this you can see this x is related to x and x prime are related. Why? So yesterday x and x prime are related yesterday जो हमने मैट्रिक्स किया था in terms of rotations and boosts जो हमने वो wash and shine in terms of rotation. Left hand side में you have x1, x2, x0, x1, x2, x2 prime, x2 prime is related to this wash of omega, shine of omega, 0, 0, and x0, x1, x2, x2. You can see this x0 is related to x1, x0 prime, x2 prime is related to x1. X2 prime is related to so in that sense you can say psi of x prime y is related by, you can write this as an exponential function of the way n cut जाएगा. You can write it as an exponential function of this phi of sigma 1 psi. Now this I in terms of size. So we can have 1, 2, 2, 1, 2. So these are the poly matrices. For example, sigma 1, 2 is sigma 3, sigma 2, 0, sigma. Sigma 2, 3 is equal to sigma 1, 0, sigma. So as a ordinary. 1, 2, 3 is sigma 2. 2, 3, sigma 1, minus 1. So you can see free in the order. From sigma 1 to how they. So यहाँ पर sigma 3 कैसे आएगा? जब क्योंकि हम 4 × 4 matrices. Okay. अगर आप sigma को अपना वैल्यू देंगे, for example, इसको अगर sigma 1 है 1, 0, 0, 1. So you can sort of like this 1, 0, 0, 1, 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0. Okay. We have to do the same thing for sigma 2. We have to do the same thing for sigma 3. Accordingly. It's basically 4 × 4 matrices. Yeah? So it's basically, since we have taken elements 1 and 2. So if it's 1 and 2, it will be in terms of sigma. If it's 3 and 1, it will be minus 2. If it's 1 and 2, it's 3. If it's 2 and 3, it will be 1. जो भी है. Cyclic, anti-cyclic. And which is being mediated by this rotation operator. Sort of matrix. So basically we have to show the Lorentz transformation of coordinates in this side prime x. So this corresponds sort of infinitesimal rotation coordinate systems. Okay, infinitesimal rotation systems. One is Lorentz boosts. One is translation without rotation. Translation with rotation. So this is basically 16 parametric equation. Now we have 16 parameters. 16 में चार डायगोनल मैट्रिक्स काम होगी 12 में से 16 एंटीसिमेट्रिक मैट्रिक्स will take change. So we come from 16 to 6 parametric equation. Okay, in terms of rotations and boosts, in which you have to show the Lorentz invariance. So this is the and these are the details. Here, this is this. sigma 3 will be 1 is to 1 is. So it will be a sort of rotation of two component on spin such that phi of x, phi prime x prime in one coordinate system is being mediated by अब इसमें आपको सिर्फ याद रखना है so it's being mediated by this तो अब ये है ना cos है ये है ना इनका iota omega so it will be cos of omega x plus iota जो भी तो इसमें ये है ना flip sin का आप करेगा स्पिनर की एक particular definition for example when we have rotation symmetry है ना flower vase को आप rotate करोगे after 360 degree it will come to its original shape you cannot इस स्फीयर को आप रोटेट करोगे किसी भी डायरेक्शन में if you rotate a sphere in any direction if you rotate a sphere in any direction so there will be rotational symmetry for example a flower vase you have to rotate it 360 degree तभी it will come to its then rotational symmetry is preserved for spinors. Okay, now what is the angle once a symmetry transformation is incorporated? वो symmetry का preserve होगा और a rotation invariance का preserve होगा along which angle? तो plus minus signs क्या होगा? So that explanation so it depends upon sign notes, sign factor. Okay. इसी को हम कहेंगे covariant angle omega mu or associated with Lorentz transformation in the same sense as just like rotation and direction of omega in three-dimensional motion. Because we have यहाँ पर x0, x1, x2, x3 Gauss equation. These are three space coordinates. This is time coordinates. These are space-time coordinates. So normally what you do spatial rotation curve. Okay. But if the time is also, then you have space-time coordinates. So you have to see invariance at least in the rotational sense. अब इसमें ये है कि equation defines the rules of psi of x. It's 2.14 this is 2.25. The appearance of half angles in this half angles in 2.24 and 2.25 is an expression of double valueness of spinorial law. Double valueness of law of rotation. So it means it takes 4 pi rotations to come back to its original value. एक हो गया 2 pi के बाद अगर माइनस का फैक्टर आ जाए इट्स नॉट कमिंग बैक आपने 2 pi तो रोटेट किया बट इट विल कम इन द नेगेटिव एक्सिस माइनस एक्सिस सो इट विल कम 2 pi channel coordinate keep the other 360 plus 360 when you rotate then only it will preserve the rotational transformation. So it comes basically the sign का factor है ना sign का factor becomes important in how it preserves the symmetry transformation. flower race में आप करोगे या अगर फुटबॉल होगी ना it will come 90 डिग्री के बाद you cannot differentiate unless आप फुटबॉल पे आप कोई पिक्चर बनाएंगे no differentiate flower race में आप 90 पे नहीं differentiate करोगे या 70 पे नहीं करोगे when you rotate it 360 only it will come back in this transformation you sign something here or you can check it so it's not double value this time it's important settings okay so I recommend you process what are spinners you just go and see it's very super fine now again what we are going to see is basically we are checking the covariance of the Dirac equation. It's a proof. We are some generalizing proof. So now again we are coming to the geometrical history also. We are going to have the similarity problem. जैसे इंटरव्यू प्रॉब्लम है ऐसा डायग्राम इसको सो जो ये मैट्रिक्स है 4 क्रॉस 4 इसकी यूनिटी प्रॉपर्टी यूनिटैरिटी प्रॉपर्टी क्या है यूनिटैरिटी को नेगेटिव यूज करिए और यूनिवर्स ठीक है so but since it's being mediated by this matrices SR it's a 4 cross 4 matrices so two coordinates एक coordinate यहाँ पर x है x prime है it's related with x prime so it's being mediated by this s it's itself a 4 cross 4 matrices so we have to see something preserves okay preservation covariance so this is so we are again going to use this property for this for the way you have defined signals in that sense so as our diagram is going to यहाँ पर अगर डैगर है तो ये प्लस माइनस है हाँ सिग्मा आई डैगर यहाँ सिग्मा आई जी दिस यहाँ पर जैसे caveat means that this does not hold for moving coordinate system. For example, for the transformation. So SL dagger is not equal to SL means. So the thing is that जो हमें अभी invariance properties है ना generally hold कर रहा है for signals, but for a particular case there will be sign plus minus sign, so it will not be equal to plus minus. So dagger into खाली dagger, sigma I dagger into the sigma I j, so it will not hold in that sense. So however, SL does have a property आप क्लियर करो, गामा जीरो किसको बराबर है? गामा जीरो है इसकी सिग्मा जीरो जीरो, आप इसको सिग्मा जीरो से बराबर है 1 0 0. You can easily prove this property. S is equal to from this. What they do? Multiply here and multiply. So in the same sense, since if you just can show gamma 0 sigma I j is equal to 0, this can be generalized. This can be generalized. Now again we have to show that the continuity equation is covariant. कौन सी वाली continuity equation? जब हमने start में किया था, start of the chapter, if you remember, यहाँ पर हाँ continuity equation में वो हमने किया था ऐसे यह रो किसके बराबर है? प्लस प्लस जो हम श्रोडिंगर इक्वेशन का सॉल्यूशन दे रहे थे, ठीक है, इसके बाद इक्वेशन जैसे हमारे पास चार्जेस की है ना यहाँ पर, इन दिस केस दैट दिस इज psi star psi, total wave function का spread in a given volume. क्या आ रहा है? If we are going to use जो हमने ये algebra किया ना यहाँ पर, so we can write this current density हमने, and for the current density को हमने ये J it was denoted by C psi dagger and psi. Now जो हमने ये algebra किया, we want to write the same thing in terms of probability current and current density. Side that the J है, you can write side that X. So alpha in terms of gamma is 0. So you can write it as gamma 0, gamma psi of X. यहाँ पर बेसिकली रिमेंबर ये कोई डिराक इक्वेशन थी हमारे पास, यहाँ अल्फा मान d sin 1 by dx प्लस अल्फा 2 d sin 2 by dx अल्फा 3, तो अल्फा अल्फा, so they were the different matrices in the Dirac equation. Here it states that this is alpha. These are different Dirac matrices. This alpha is the value in terms of gamma. So can we write it like this? You can say J nu can be written as gamma 0, gamma psi. If you flip it, J psi prime x prime over now we are coming back. तो यहाँ पर ये जनरल है, so we are coming back the way we define S. इससे पहले वाला S, the rotational transformation, infinitesimal rotational transformation. So we are going to enter it here from the left hand side and from the side that S dagger S is equal to 1 or S inverse S dagger is equal to 1. उससे फर्क नहीं पड़ेगा. So if you want to write like this, S inverse gamma S sin X. C times. So if you remember last class in SAT, A mu gamma mu is equal to S A gamma mu S A. It's equal to this. So you have to get like A mu in terms of ये भी गामा है, mu कैंसिल हो जाएगा, the A mu I. A mu can be related with A mu. Via this matrices. So you can write it like this. You can write it like this. अब इस सब को in terms of हम ये है साइड can be write like this. Identity G into X is a Lorentz 4 vector. So basically what we are trying to show? We are trying to show this J mu है ये है Lorentz 4 vector. Lorentz 4 vector means we have space-time coordinates. We have space-time coordinates and we have a factor of root of 1 minus b square निकाल वाला equations. So we have at the end, if you want to write this current density in terms of size and cycle in terms of these S matrices, these are 4 cross 4 matrices currently, you can write it in terms of current density. And current density may have space-time variables. So you can say, if you want to write B, J, U, Y, dx u, it will come out to be 0. It will come out to be 0. This means sort of invariant. Or invariant probability is there. Invariant you can have, so the whole point of this exercise was to show what? कल हम देखा था covariance of the Dirac, उसका proof. Now we are generalizing the same proof for infinitesimal rotational transformation. There are two coordinates psi x को psi prime x या x prime को x prime के साथ relate करो, where some rotation, infinitesimal rotation matrix, which is shown S. S itself is a 4 cross 4 matrices. But वो 4 cross 4 matrices में क्या है? It's represented by signals, gammas and sigmas. They are internal Dirac matrices, which have certain properties. Okay? And they represent some spin. And at the end, if we want to invoke original solidity, original wave equation is psi hat. Using this algebra, we use for the invariance theta on the space-time coordinates. This was an exercise we will continue to do. Space reflection test.
space reflection bilinear covariant. First unit में आप 2 इंटरवल्स